Welcome to the React Show, brought to you from occupied Miwok territory by me, your host, Thomas, and Broken Assumptions. Is your new web app secure? How easily can someone get into it, take over accounts, or even steal user data? Can someone take over the site or even use it to distribute malware? How do you even know? Don't worry. Today, we're going to cover the basics of web application security so you'll know where to start, what to focus on, and how to progressively harden your web application. Thank you so much for joining us. I'm fresh off a bicycle tour in the San Gabriel and Santa Monica Mountains down near Los Angeles. And I'm really excited to jump into the basics of web application security. Maybe more. Maybe I'm too excited. It was a great time. I had a great time and I'm just feeling refreshed, So we'll see what happens. But I did want to begin with a couple quick announcements. So I'm super excited to present the general availability of the reactors. I don't know. It's the silly name I'm giving to my new initiative to expand the community around the podcast and programming and React in general, and just try to help all of us get better at programming and React, as well as provide a place to just hang out. First, you can sign up for a premium version of the podcast that includes all of the regular episodes ad-free, as well as bonus episodes. And not only do you get more, but it also really helps to support this show. And you can actually sign up for as low as $1 US dollar per year, trying to make it as accessible as possible as well. But whatever you're able to do, if you're interested, it makes a huge difference in my ability to produce high quality educational podcasts. And I just super appreciate any support anyone is able to give. And second, you can join for free on our new Discord server or channel. I'm still learning Discord, whatever it's called. But yeah, you can come hang out with us, ask questions about programming or React, or even tell me how I was completely wrong about something. I'd love to hear that too. So if you want a little break from programming too, I also post sea slug pictures or other fun adventure things. I want it to be a fun space to hang out. So we can learn, but we can also just be friends and hang out with each other, right? But yeah, no matter what the reason, we'd love to have you come join us on Discord. Links for Discord and the premium podcast feed will be in the description or summary or whatever, wherever you find this podcast, as well as on our website, of course, thereactshow.com. So speaking of Discord, that's actually where the idea for this episode started. So I just want to say thanks to this MC Kraken on Discord for the initial questions about web application security and feedback on my early outlines of this episode. Right before we jump into the main show, though, I do want to give a real quick disclaimer. You are responsible for security on the things you work on, not me. This episode is just meant to be a primer on web application security and is absolutely not an exhaustive resource and is not a replacement for doing your own security analysis on your own projects. My goal is to provide a quick overview so you can know where to start and, so you can dive in deeper on your own projects, and also just to outline methods and approaches I take to, in general, keep web applications more secure. And of course, just like my coverage of this topic is not entirely exhaustive, security will also never be exhaustive either. Security will never be 100%. Every system that we build or work on will have holes. The goal of security is not to make a perfectly secure system. That is unreasonable and essentially impossible. The goal is to make the cost of attacking a system vastly outweigh the rewards. If someone, like for example, if someone breaks into your system to steal user data, but finds out you don't store any user data, well, you win there. You've made the reward essentially nothing. In that context, at least, there might be other reasons they might break in, but yeah, that the whole point of security, and I think this is something that if you're not super familiar with, when it comes to security, might be a little bit surprising. But the entire point is not to build a perfectly secure system. It's not to come up with perfect security solutions. The point is just to make it so it's too costly for people to break in relative to what they'll get if they succeed. So that's where my thinking when it comes to security is sort of comes from, which is that I call it sort of scaled security. So trust in a system should be proportional to the hardening effort. So for example, when you're first launching your web application, let's say you're just going to share it with a couple friends and it's not, carrying out like financial transactions on people's behalf. Maybe you're using a service for that, but whatever. Like the point being, you're launching a new application. It doesn't have, a ton of users. The users it does have are your friends, and they understand this is the first version and it's going to have bugs and it's not going to work well. In that case, it might be perfectly fine to spend very little time on security because the trust that people are going to have in this system are going to be very low. So if people are approaching your system and being like, oh, this thing is probably going to leak all my data and it's not secure at all, I'm not going to put anything that I care about into it. And, it's not maybe inherently creating data that you don't want to share or something. Like there's a lot of cases where I think when you're first starting, I wouldn't say all cases, there are cases where you need to care right from the beginning. But I think for a lot of people, like, maybe you're creating a site to, track some recipes or something, and you want your friends to try it out a little bit before you make it a larger launch or something. It's still good to be aware of security things, but it's not as important to have a super hardened system at that point. So that's where I think of scaled security. So I try to scale systems based on, how much trust people have in the system. And, a lot of cases people don't know how much to trust a system. But as the software engineer, we can better evaluate how much trust they should have in a system as well. And also evaluate how much trust people think they have in a system. And so we can scale our security based on that. So if we understand that our software is creating valuable data, we need to scale our security to match how valuable that data is. So that's kind of my preface to all of this, is that you're never going to build a completely secure system. But the level of security you provide should proportionally match the amount of trust that people have in your system or should have in your system if they understood everything it did. And, proportional to the rewards somebody's going to get for breaking into your system. I mean, if you don't have anything valuable, the security doesn't matter as much. There's still other aspects to security. Maybe somebody can take over your server and use it to infect your users with malware. But that's still a reward somebody gets for, the security vulnerability. But the entire point of this is just that it's going to sound like a lot, probably, if you're not familiar with this topic. Like a lot of the stuff I'm going to talk about, it might sound kind of overwhelming. But my point is just that, think of it in terms of like a scale. We're not trying to have perfect security. Not every application needs the same level of security. We need to develop an ability to tell how much security a system should have and engineer solutions for that. I mean, that's part of being a software engineer is understanding these trade-offs. So I'll try to help guide us along that journey throughout the podcast, but I wanted to start with that so that people are able to frame all of this information in a more useful manner. And one other thing I wanted to talk about before we get into sort of the main, meat of this episode is that I'm primarily going to be talking about technical security. So you have, I'm going to presume you have a React-based web application. But I think a lot of this will apply to any web application. I'm specifically going to speak to React. But in general, what I'm going to talk about applies to everything from a technical perspective. But the more important thing in any web application or any system is going to be your operational security, not your technical security. Technical security is important. Operational security, though, is where you should start. Most hacks into systems are not via breaking in, like hacking into the system, using some vulnerability. Most systems are broken via social engineering. So our focus in this podcast is going to be more about technical security, like how do we secure applications from a technical perspective and vulnerabilities. But I just wanted to make it very clear that the place you should always start is operational security. And what I mean by that is like phishing attacks or, giving people access to an admin account that shouldn't have access or that you don't trust or those types of things. The people in your systems are always the weak point. Even very insecure technical systems, usually operational security is the bigger deal. Like you need to take care of that first. I just want to mention that, and I'll make some other references to it because it's so important. But the main point of this will be on technical security. All right, so let's get into it. The best way that I think to start is that we need to look at where people are coming from when they're trying to crack your system, when they're trying to hack your system, because we need to understand that before we can understand how to make secure systems. And so I call this thinking like a cracker. Hackers, they're different than like the way they look at your systems is different than the way you will look at your system as an engineer. I found this from, I think it was mouser.com, like a blog post, and I thought it was really great. So they say, hackers follow paths. They will continue to follow a path until it fails to progress them forward on their mission. And so we need to start getting our head into thinking in that term, those terms. When you're looking at building a system and being that engineer, you're like, okay, I've structured my API this way and my client this way, and you're thinking of it in those terms. The way that a hacker thinks of things is like, oh, is there a vulnerability in the login system? I'm going to try a whole bunch of different things to try to get into this login system. Is there something I can learn about the way the sessions are organized or the session tokens, or is there a weakness in the SSL certificates? Can I intercept communications? They're gonna, the way they think of it is, okay, how do I break into the login system? And they might try a bunch of things. They can't break into the login system. Then they might move on to something else. Oh, can I, break into this other part of the system? Can I directly break into the server, using some other program that is running on the server, not the main web application? Is it not firewalled off? I'm going to port scan. And so that's the way that hackers are really looking at your system. And so it's important for us to put on our hacker hat, so to speak, and think about systems that way as well. And just to note, throughout this episode, I'm going to sort of talk like the hacker as a real person sitting at a keyboard, typing this stuff in, trying to break into your system. And that could be a thing. Generally, though, all of this stuff is encoded in bots that try to do it automatically. It's kind of not relevant because the people that create the bots, create them to do the same thing that they would do if they were sitting there in front of at their keyboard, right? I just want to note that. It can matter in terms of how quickly somebody is able to do something. You can make a bot that, submits, tries to break into your system by guessing random passwords, right? And if it can submit 10,000 requests per minute or whatever, that's going to be open up vulnerabilities that wouldn't be there if somebody had to manually type in a password every time. But that's not so important. Once you get into this and start thinking about it, it doesn't matter as much. So I'm just going to talk like it's a real person, but you can imagine it's actually a bot sometimes, right? Anyway, so going back to our hackers follow paths. Another part of this is that it's really important to try to get assumptions out of your head and just assume that all of your assumptions will be wrong. In fact, this is generally the place I start. So if somebody says, hey, can you perform a security audit of this system? Generally, what I do is I'll look at the code and be like, okay, what are the programmers assuming? One great example of this will be a lot of times on the server side, they will assume that the client they're talking to, the web application they're talking to, is trusted. When you're programming the server side, you're not usually being like, okay, what happens if somebody creates a duplicate of this website that's malicious and connects to my server and starts sending me requests? You might, in general, think okay, let's make a secure API, right? But usually what I find happens is people will be like, oh, okay, we'll take these couple, security measures to make our API secure. And then from then on, assume that the web application they're talking to is the one that they wrote. And so I'll look at the code and be like, oh, okay, they're assuming requests are going to come in this order. What happens if I don't send in requests in that order? Can I just jump ahead in the login process, for example, and send a request that, the server thinks is going to come after 3 other requests? And so, yeah, I think when we're looking at how to think like a hacker, this is by far the best place to start. It's just assume all of your assumptions are wrong, and even if your assumptions happen to be right, it's a really great practice. For example, one way you could look at a system is be like, let's assume that our HTTPS layer, our TLS layer, our security certificate system doesn't work. Let's assume it's broken. Normally, you assume that works fine, right? And maybe it will work fine. Maybe there's nothing wrong with it. But part of this learning process is to be like, okay, let's assume we broke something. Let's assume we implemented it wrong, or there's a bug in whoever wrote the library that we're using to provide that. What happens then? If somebody's able to get past this, what do they get? Where can they go next? And so thinking like a hacker, this is the way that I usually like to think about it. It's like, okay, let me look at this system and just start making a bunch of assumptions that things aren't the way they seem to be. And so that could be like, let's assume we have a bug here. Like, let's assume somebody can view people's bank account numbers. Let's assume somehow there's a vulnerability we didn't know about and people can view this data in our database. What happens then? What can they do with this data? That's the way I like to frame it. That's the place I like to start when we're getting into all of this. So it's like some other examples might be, don't assume that user data will only be used in the original code path. And this is another part of security, and that is, don't assume that future engineers at the company will make the same assumptions that you do and think in the same way that you do. Going back to this user data, you might be like, oh, I don't need to sanitize this data for cross-site scripting because it only ever gets used in this specific way, which never gets sent back to the client. Well, maybe 1 year later, a new engineer, implements a feature that sends the data back to the user, not realizing it wasn't sanitized. Like, they made the assumption it was. And so that's where, I just try to get in this mindset whenever I'm, doing a security audit or writing code like this, where I'm like, okay, let's assume it fails, even though I think it won't. What happens? And that will really help you just start learning. Like, we don't necessarily need to do anything with that yet, that information, but it's important to just spend some time practicing that. Like, one of the best things you can do when you're doing this is even spend like a few hours or a few days, like looking at code, looking at your own sites, and just trying to get in that mindset of, how can I think like a hacker to hack into my own systems? This will absolutely pay off. It will really help start retraining your brain to think and view your code in a different way that will help you create more hardened systems. Another aspect to mention when it comes to assumptions is that I find a lot of engineers assume for some reason that people hacking into a system, they just exploit one thing. That's almost never the case. Many attacks involve multiple attack vectors. For example, maybe the hacker's looking at your system and they say something like, oh, look at this. It doesn't verify the phone number matches the account. It only verifies the email address. I can use that to change my account to someone else's phone number. I don't know what that will let me do yet, but I'm going to find out. And so, maybe they make that change, they get somebody else's phone number, and then maybe that allows them to bypass the two-factor authentication or something like that. So when you were initially programming the, form to update somebody's profile and set the phone number, you were just assuming that, somebody setting this number was an authenticated user for this account, not realizing that your API just lets anyone send a request in here and update the phone number, right? And so that's kind of what I'm getting at. And usually it'll be usually people break into a system using something that seems really minor. You're like, I don't need to secure that because it's not that important. But they get to that point, which allows them to exploit something else that is more major and more major and more major, and they can take over more and more of your system. So it's important to also, when you're thinking about this path-based hacker approach, to keep that in mind. It's not just one vulnerability. It's multiple. Another example, like the session token is stored in the cookie. Is there a way I can get access to cookies? Oh, look, I put data, I put data into this text field in, some other, into a form, and it shows up on other people's feeds, right? And it isn't escaped. They didn't escape this code in some way. So I could add some JavaScript on maybe my profile, and then it will show up on everybody else's, feed, which means it's getting run in everybody else's browser. And that JavaScript will let me read their session token cookie. That's an example, again, of how you can sort of go through this path. Like, you have a vulnerability essentially in two different places here. So always remember, defense in depth. Never rely on one piece being secure. Try to secure all the pieces. Try to make the assumption that somebody broke through the earlier layers. Attacks are usually a chain. They might start with something that seems hardly worth securing. But once you get past that, you get to progressively higher levels of trust within the system. All right, so I like to think of things in a sort of methods-based approach, right? If you've listened to this podcast, that's the way I like to do it. So, that's what I want to talk about next is how can you do this in sort of a methodical way? So we've talked about how to think like a hacker, but how do we actually apply this? So this is what is called the threat modeling process. If you really want to get into this, you can look up way better information. This is just an overview. But this is kind of generally the method I would use if I'm trying to do some sort of security audit. So to do a threat model, the place that you generally start with, there's other sort of ways to do it, but I like to focus on what are called the assets. Identifying assets. So assets are things a cracker might be interested in. Maybe this is personal data, session tokens, bank account numbers, anything that has value to someone else in your system. These are your assets. So you can just list them out. That's what I have to do. Just write a big list. The next thing you'll want to do is identify and rank threats. So then you can go through that list and be like, okay, what are the actual threats to this data? So let's say it's personal data. Somebody could steal that data, disseminate it on the internet at large. And part of this is like ranking and sort of rating how big this threat is. So let's say you have very minimal personal data, a first and last name for a site that is just for storing recipes. Well, if this data gets leaked to the internet, I mean, it's not great to leak anything, but what value does that really have? I mean, maybe not a lot if that's all it is. But maybe you're, Ashley Madison and you run a website for people to cheat on their partners. Leaking their first and last name could be absolutely devastating. So this data might be worth a ton. You might be like, okay, this is a really, really valuable asset. We're going to give this a high rating. I usually will go through that list of assets and just sort of, it doesn't, it depends on how thorough of a security audit you're doing. If you're in a new web application, it can just be pretty quick. Like, oh yeah, this is really important. This is not as important, whatever. So that can be, many different things too. It could be like, oh, what if somebody can run their own code on our server? What if somebody gets admin access? Definitely if you're going to do this, you can look up like lists that people have created that will give you more ideas. But yeah, you can have this asset list. You can identify and rank threats. Another example might be a session token could be used to impersonate another user on the system. What does that give them? What does that let somebody do? How much of a risk is that? Or a stolen bank account number could be used to steal someone else's money. I mean, that seems like a big risk, but you want to do it in a sort of relative way. Maybe there's a bigger risk in your system, and that's number 3 on your list. The whole point here is just to sort of give us a way to prioritize our efforts. So the next thing is a threat analysis, which is basically the probability that a threat occurs times the cost to the organization or the users of your system. So this is, being like, okay, we've got our personal data and maybe it's worth a lot. How likely is that to actually be disseminated, broken into, stolen? Maybe you encrypt the data and you take all sorts of other safeguards against it or something. So the probability you feel like is lower that it might get stolen. Well, that might move it down on the list of your priorities. Basically, at this point, this is where we start also exploring attack paths. So we'll look at our system and be like, okay, if somebody breaks into the login system, that gives them access to this. If they're then able to elevate their login to an admin account, that gives them access to these things. But to get there, they need to break in 3 systems maybe. And so you're like, well, that seems less likely. So that's basically just this process. You can look it up if you really want to know it, but the general idea is just like um, get an idea of the paths somebody would have to take through your system to get to these assets, and rate how likely that is times the cost of them actually succeeding at it. Another thing I like to do at this stage is just to sort of note how each of these paths is mitigated or not mitigated. Maybe part of your system is you tell users, hey, we don't protect against this. That might be valid. But yeah, so that's what I would do at this stage. We have our threat analysis. And so that's sort of a very abbreviated version of threat modeling. But this is sort of where I start. I look at a system, I identify the assets, I rank the threats against those assets, and then I do the threat analysis where we figure out sort of the cost, priority, and the paths a hacker might take through your system. Once we have this data, we can prioritize our security efforts. We can look at the top of our list and be like, okay, this is the most important thing for us to secure. These are the paths we can imagine somebody taking to get to this asset. What can we do to further mitigate this? Like maybe we're like, okay, we need to do better. You can look at each of those paths and be like, okay, what can we do to stop somebody getting through this layer? What can we do to stop somebody getting through this layer? So this provides a nice method of doing a security audit and making your system more secure in a methodical way. All right, so next I want to talk about basic attack vectors. And this is definitely not an exhaustive list, but when you're writing a web application, there are very common attack vectors that you should be aware of, at least. And first I'm going to talk about operational security and social engineering. Then we'll get into the technical things. So something that I want to note that a lot of people forget is it's super important to secure your domain registrar, your host, things like that. If somebody can break into like whoever you've registered your domain with and take over your domain, boy, can they really do a lot of harm at that point. And so that's not code you've written, but keeping that secure is super, super important. So, remember to keep those types of things in mind as well. One thing that I highly recommend you do is use a hardware security key. I honestly think most engineers should be using them. So a hardware security key is basically a physical device that's got cryptographic stuff on it. I'm not going to go into all the details, but it essentially means that if you use it for two-factor authentication, things like that, it basically means somebody can't get into the system unless they physically have that hardware key. And that eliminates a massive host of vulnerabilities when it comes to things like, securing your email, your domain registrar, things like that. So I really recommend all engineers, software engineers that work basically on anything, should spend some time understanding how to use a hardware security key or at least like a two-factor authentication app on their phone, which is also good. The reason why I really recommend a hardware security key, though, is because then you can use WebAuthn, FIDO. You can look these things up, but they essentially provide phishing protection as well if you use them correctly. So like when I plug my hardware key into my computer and I log into my domain registrar, I do my username and password, then it says, okay, verify with your security key. And you can't get into the system unless I enter a code that does cryptographic stuff on this hardware security key and I physically touch it, hit a button on it. And using public key cryptography, that process verifies the site the request is going to is actually the site I think it is. It's the site I initially set up this hardware security key on. And so this is super valuable because it eliminates a lot of the phishing attacks that normally take over people's accounts, where they, think they're on their domain registrar's website, they enter their username and password, and then, maybe even they enter in the two-factor authentication code from the Authenticator app on their phone. But turns out it's a completely fake site. And this fake site in the background is entering all these details into the real site and giving the hacker access to these things. If you use a security key correctly, you eliminate a lot of these things. So I definitely recommend that. It's kind of a pain. It's extra work, but in my opinion, very worth it. Anyways, you can do what you want, model your own risk and all this, right? I'm not going to tell you what to do, just a recommendation. Just one other thing I want to mention is secure your email and anyone else like at the company that has an important email account. And don't use SMS for multi-factor authentication, two-factor authentication. It sucks. A lot of people, though, don't remember to secure their email. And I think even more important, secure that this one is hard. But if you can, make sure that people with important emails in your company also have them secured, like the CEO. Because a great way that people social engineer their way into systems is the CEO is like, I'm not super technical. I can't handle all this like extra security measures. And so they don't really secure their email account. Somebody hacks into their email because it's easy to hack into. And then they send out emails to other people at the company telling them to do things, impersonating the CEO or CTO or somebody high up in the company. And a lot of people, like engineers, they're probably not going to question that. They get this email from the CEO being like, oh, this is really important. Can you take care of this by XYZ time? And basically let a hacker into the system. So just a word of warning. Anyone with like authority in a company, they need to secure email and chat programs, anything like that. Anyways, all right, done with operational security. Let's get into basic technical attack vectors. So these are pretty classic. I'm not going to go into anything wild at this point. There's a million ways you can hack into a system, but we're going to talk about just a few major ones. So database injection. If you have a database of any kind in your system, you run the risk of injection. So what is injection? Basically, think of it this way. Let's say you have an SQL-based system, and you put user data into the SQL queries. Let's say you just made the queries up with a string. You interpolate or append user data into these queries. Well, what if a user of your system puts SQL into their data? Then you will be running like the attacker's SQL code against your database. That's horrible. It can let them gain access to basically everything. This is super classic. I'm not going to go into all the details again, but database injection is one of them. How do you avoid that? Don't create your SQL just using plain strings. Basically, most libraries today will provide a API, and it'll be the main API where you pass in user data separate from the query itself. It's parameterized is what it's called. Like if you use an ORM, object relational management system, that type of thing, generally it provides this for it. But take like 5 seconds and look into your system and look at how to do this right. Don't make the mistakes that people have made in the past and do it wrong. This one should be pretty good these days. Just take 5 seconds to understand how your system works. The next one is cross-site scripting. And when it comes to React, this is one definitely to be aware of. So cross-site scripting is basically an attack vector where an attacker is able to run their code on your website, within your web application. This is something I mentioned earlier. So somehow an attacker, maybe they put JavaScript into a form field on your site, and this JavaScript gets served up to other users in some way, and runs on their system in their browsers. This is very bad. Again, this can basically give somebody access to everything in your system eventually, or do lots of other nefarious things. Very bad. Cross-site scripting, it's a very classic attack vector. But specifically, when you're using React, there are a couple things to be aware of. Never, ever put data that users have entered into your system inside dangerously set inner HTML. I think that's the property name. Unless you really know what you're doing and you really actually understand cross-site scripting and you know how to sanitize that data, just don't do that. And the other thing is, don't put user data into attributes of components in React. Things that could be passed through as like a style property or something like that. This one's a little bit more nuanced in understanding it, but from a blanket perspective, if you're using React, you can put user data in like the body of a HTML tag. Like, let's say something eventually gets rendered out as a div, and in the body of this div, you put, some data the user has entered, their name or whatever it happens to be. That React will always automatically escape for you. So you don't need to worry about cross-site scripting if you put, in fact, not only do you not need to worry about it, you just need to be aware that React will escape this for you. So you don't need to escape this data when it goes into your system necessarily. In fact, I'm going to talk about that a little bit more in a second. But the thing to be aware of is if you just generally use React in a normal way where you just render components and, include user data in that output, you'll be fine. Just don't put it in attributes. Don't be like style equals $user data or whatever. Like, don't put it inside attributes. Don't put it inside dangerously set inner HTML, and you'll generally be fine. React is great. It takes care of this for us. When I was originally using, things before React, this was not always the case. And boy, it was much easier to have cross-site scripting. But yeah, if you're using React, it's pretty straightforward. I have, though, definitely run into cases where people have put user data into attributes. And even one time I had somebody like putting it into dangerously set inner HTML and they thought somehow that was more secure. No, don't do that. But yeah, so that's cross-site scripting. Another one to be aware of is request forgery. So this is like one example would be server side. So don't use user data to access local resources. So let's say you had this brilliant idea where you were going to take someone's like name and use that as the file name on your file system to store some data about that user. I mean, I don't know why somebody would do this, but just to give you an example, what you're going to do then at some point in your system is open up that file. Well, if somebody can put any data they want for their name into that field, you're basically going to be running hacker's code locally on your system. Again, you can look into how this works and maybe you can escape it. Or create a whitelist or do this in some way securely. But by default, you need to be careful whenever you're opening a network address, a file on your system, a database, credentials, anything local to your system or to your infrastructure. Don't put user data into it, because then somebody can use this to forge, requests to local I/O within your system. So that's another one to be aware of. This can also be clients forging requests to the server, your client forging requests to somebody else's server. It's just another vulnerability to be aware of. All right, so those are the main web app-based threats that I'm going to cover. There's a million more, but that's always basically where I start with. For historical reasons, those things have been exploited more than basically anything else. So definitely make sure you get those things right. Luckily, libraries often do a much better job today than they used to in terms of protecting us against those things, but at least spend a little bit of time to understand what your library does to protect against it, and how to use it effectively. Next, I'm going to mention a couple other areas that I find people often make mistakes on or don't know about when they're getting into this. So another one would be log security. What are you putting in your logs? This is kind of the same as like, don't put user data into logs because, or at least you got to be careful because a lot of times logs aren't treated very securely. And so this could be an easy way to leak user information or even let hackers run code on your system. A great example of this, which it wouldn't be running on your system, but something people don't realize is that in JavaScript, console.log and console.error essentially are the same as eval. So anything that, if you put user data into a console.log or a console.error, that essentially allows somebody to run arbitrary JavaScript on your client. Maybe this doesn't matter. Depends on your system, but it's just something to be aware of. And same on the server side. Be really careful what you put into logs and be careful what you do with logs. I think people forget about this a lot. They're just like, hey, let me log this data. I want all the data. Log it all out. That could be a threat. Be careful what you do with logs. And the next thing is a big one, I think, for people getting started, which is authentication and authorization. You got to make a login for your system, right? Most systems have a login. This is where so many mistakes have gotten made. I have found so many vulnerabilities in login systems. A lot of times people get sort of the basics right, like username and password, or they're using some library to do this for them. But oftentimes where they go wrong is identity. And like identifying who a user is or updating data in the login process. There's just a million ways you can do this wrong. And so my advice is always keep this as simple as you possibly can. Even if you're using some library to handle this stuff for you, just keep the implementation of that library, that code, just keep it super simple. Just make it only about, one thing, logging in. Only like one section is authorizing the user to get into the system. The next section might be identifying the user and setting up their session token, but just keep it really simple. What I have found is these login systems just balloon. It's really bad. I think what happens is people build the initial one and then somebody's like, hey, can we add this feature to like automatically do XYZ after a person logs in? And so people will start putting other code into the login routines. And this is extraordinarily dangerous. Just don't do it. You make that a separate thing, completely separate. Don't update data on login automatically unless you're super, super, super careful. Like I see this all the time too. People be like, our first set of users didn't have this data set. We're going to set it for all users when they log in, or update a phone. Like maybe somebody puts in their email and their phone when they log in, and somebody like as a second factor or something. And or I've seen like they log in with both, I don't know, multiple pieces of data, and people are like, oh, we're going to save the user a step. We're going to update this data for them when they log in. Don't do that. Never do that. It's like the worst thing ever because without realizing it, you often open up vulnerabilities where it allows a hacker to inject their own information in those paths and essentially log in as somebody else. So just something to keep in mind. Make your login systems, your authorizing users and identifying users, as simple as you can. This one is, I don't think I can stress this enough. This is by far the place that I've seen the most issues. Like generally at this point, those other things like database injection, cross-site scripting, that kind of stuff is, I don't usually see glaring issues here. People are generally aware of it, and libraries do an okay job of handling it. But when it comes to actually implementing this stuff, especially for authentication or authorization, giving somebody admin access, people overcomplicate this. They add features to it. Just don't do it. It is a recipe for disaster. All right. So enough of that soapbox. Let's talk about data validation. So I think this is the user on Discord. This is initially what they were asking about is how do I validate data or filter data or escape data so it's safe to be in my system? And this is where it seems like I think I started here too, where I was like, oh, okay, I get user data. I need to escape it right away and make sure it can never do anything dangerous. And this can actually be dangerous in of itself. Let me give you an example. Let's say you have a system that, stores data using SQL or something, right? And then later on, you send this data back to the user, you render it using React or something, right? The way that you escape data for putting it in an SQL query is different than the way you escape data for rendering it in React on the web. And in this case, maybe there's no conflicts. But maybe you have a markdown parser or whatever. There's many different, systems, right? And the thing is, they all need data to be escaped differently. So the approach that I think is safest is only escape and you should escape and then unescape data when it goes in and out of systems. So when you're putting data into your database at the database, library level or whatever, that should be automatically escaped for you in the specific way the database needs it to be escaped for. And then when you take that data out of the database, you generally want to unescape it back to its original form. So that at every layer, you're working with the data in its original form. And the reason why this is important, initially when I got into this, I was like, oh, okay, I just want to escape it once, right away when the user enters it, right? And then I'll be good forever and I can just rest easy being like, my data is validated and it's good. I don't need to worry about it. But what can happen is the way it gets escaped for one system could create vulnerabilities in the next system's escaping thing, right? So let's say one system you escape data by adding a double slash in front of it or something, or adding a slash in front of slashes. Well, maybe the next system sees that and thinks, oh, that's how you indicate safe code to run, So you just need to be super careful to not end up in those situations. And that's where I tell people escaping and validation should occur at the layer that it's relevant for. Don't try to anticipate everything at the top layer. Don't be like, okay, I'm going to escape it for SQL here. I'm going to also escape it for JavaScript here and whatever, right? Don't try to do that all up front. Do it at each layer and do it automatically. And another reason for this is you don't know how the data is going to be used in the future. Somebody comes in later and might add a layer that does something that needs escaping or unescaping. And they might not realize what you've already done to the data. Generally, things are done right. You shouldn't really need to worry about this. But I think we're still at a state where you absolutely do. I have absolutely seen this many times over. People are like, okay, the user entered data into the form. I'm going to escape it for rendering out in React at this point. That doesn't make any sense. Don't do it that way. So yeah, that's my spiel on data validation. Now, that's in my mind separate from, I guess I would call that data sanitization. There's also what I would, call data validation. Maybe when somebody puts in their first name, we don't want it to be a bunch of random symbols or, we don't want it to include certain things. In general, just because maybe it makes it confusing. Maybe you're like, oh, people should only be able to enter their username as ASCII characters. That way they can't use a Unicode character that looks like another character to try to spoof names or something. That would be the way I would think of data validation. And that's something you can do immediately when the data goes into when you get it from the form, from the client, whatever. The other part is, and I forgot to mention this, should have mentioned this, data validation should always happen on code that you control. So validate and sanitize data only like on the server if you have a web application infrastructure. Never, ever, ever rely on client-side validation or security. You can have client-side validation where on the client you reject things and you tell the user, hey, this isn't valid. You need a password that's longer. You need a password that includes this or whatever. But you never trust that. You can't trust that because somebody could create their own client, send their own requests, right? You always have to do those things on the server or code that you control. All right. The next thing is libraries and external services. So this is a big one that people often don't treat the same as the rest of their code. But if it's involved in your program, I consider it from a security perspective to be the same. So keep your libraries up to date from security vulnerabilities, which is a pain in the JavaScript world, but that's how it is. That's an obvious one. Keep things up to date. The next one is check security before adding things as dependencies to your project. This one is kind of a pain. A lot of engineers I find, especially front-end engineers, don't do this and don't want to do it, but if you care about security, you should. So you're like, hey, I want this library to do this thing for me. Take a few minutes at a minimum and do a quick threat analysis. Look at the documentation, etc. I'll tell you what I look for. So if I'm going to add a library or a service to my project, when it comes to security, I look for a number of things. The first is, does this library have good documentation on how to implement the library securely? Most security vulnerabilities actually come not necessarily from like a vulnerability in the library itself, but people implementing it wrong. So having really good documentation there that says like, okay, this is how you do it securely and correctly. This is, don't do these things, I look for that in the docs. If it doesn't have that, that makes me a lot more cautious because I'm like, did the programmers think about security at all? Like, how do I do this securely? Are there things I should be aware of? If it doesn't say, that's a big red flag to me. So good documentation will also include the types of attacks that the authors are purposefully not addressing. And this is always going to be the case. They might be like, hey, this is something we don't feel it's our responsibility. You need to handle this on your end or something. But basically at this stage, I'm just looking, does the documentation include this information? If it doesn't, again, sort of a red flag where I'm like, do these people know anything about security? Are they handling it right? It's just sort of one of those things that makes me spend longer researching it, And let's see, the next one would be look for, do they have a public policy in place for how they handle vulnerabilities? This is another good indicator that they're paying attention to security. Kind of the last general thing I look for is, do they have good documentation on a high-level approach they take towards security, and does it make sense? So basically everything should have this in some form or another, even if it's just, hey, we don't really need to do anything for XYZ reasons. There needs to be something. And like for, say, a library that has to do with authentication, it should be like, okay, this is how we store data. This is how we manipulate data. This is how we defend against these common attacks. That type of documentation needs to and should exist in a high quality library or service that you might be integrating. As a quick example on Discord, it was asked about the auth library and identity service called Clerk, like Clerk. So I did this analysis real quick, and my results were there were not good documentation on how to securely implement it. It was pretty almost nothing. And so this is a huge red flag to me. There should be extremely explicit data on an authentication library on how to securely implement it. That is like the first thing it should have is to do this securely, do things in this way, follow these things, don't do these things. It did not have good documentation on it, or if it did, I couldn't find it, which is just as bad. That needs to be front and center. So I didn't like that. I also looked into sort of the high level approach they took towards security, and that gave me some sort of maybe not red flags, but like orange flags, like sort of warnings too, because this is something that you might not know if you're not as familiar with security, but that's fine. They use some relaxed security policies around session token storage that require extra work from the people implementing the library. And that in and of itself might be fine, but I don't feel like they highlighted this very well. And then the third thing I found is that it requires a ton of trust in the service and the company themselves, since they're handling everything, including session tokens, identification, that type of stuff, but they really didn't provide hardly any details on how they internally secure this information and manage it. They might do a fantastic job, but I couldn't figure out if they do or don't, or if they care or don't care. So this was a pretty big red flag to me as well. And my overall conclusion was I would be pretty hesitant to use a service like Clerk for these reasons. I think there are better libraries and systems available within the JavaScript ecosystem. Maybe it's fine. Maybe for your system, you're like, okay, all those things are fine. I don't really care. It's not a big deal. But personally, I was like, okay, there's a lot of red flags here. Anyways, that's my approach for how I look at integrating libraries into my project. And I'll briefly touch on what I call external services too. So this might be like Google Analytics or something where like they just give you some code to put in your project or a library or whatever. But they're sort of like Clerk where they are handling everything for you. Your app might be the most secure thing in the world, but if you're giving other services access to run code on your system or, whatever that might be, they need to be just as secure as your thing. So you need to perform a threat analysis with them or in some way, keep that in mind, right? Let's see. A few other things I'm going to go over real quick are keep backups, but also do it securely. If something goes wrong, it's really nice to be like, oh, okay, maybe we don't understand everything yet, but we can restore from a backup. Or you can use the backup to see what maybe some data got changed by a hacker. You can use the backup to look at that. So in general, backups are always good to keep. It's also important for security. Another thing is keeping logs and intrusion detection. Can you find out if somebody did hack into your system? How do you know? What did they do when they were in your system? So this is another aspect of security that often gets overlooked. It's important to have mechanisms in place to detect when somebody has done something unusual. I'm not going to go into all that, right now, what that means. You can research it yourself, but something to be aware of. Another great piece of advice is don't store data that you can't secure or that you don't want to put the effort into securing. This is an easy one that I think a lot of people forget. Like when you get a feature request to capture some new data, be like, hey, is it worth it from a security perspective? Maybe this data is super valuable to a hacker. Are we going to invest in actually keeping it secure? And then the last thing that I want to talk about is my approach to writing secure and safe code. it's hard to keep all of this in mind all the time when you're writing code, right? But I think there are a lot of things that we can do as engineers to just in general write better, more secure code. Um, so what I always advocate for are systemic solutions. The first thing is don't rely on programmers remembering to do things. Like if there's some part in your application where you're getting data from the user and a programmer needs to remember to call some method to sanitize that data, that's horrible. Don't do that. Figure out a way to architect your system so it gets handled automatically at that layer or whatever it happens to be. A lot of people, again, don't do this, and it really bugs me because it's just too easy to get it wrong. And, whether it's in refactoring or some other engineer that doesn't know about it, or you just forget, don't rely on manual methods. Create systemic solutions. Use or create a library that just guarantees it always gets sanitized correctly at that level without the programmer having to do anything special. That's absolutely critical to just in general writing robust, secure code. Another approach I use when writing code is that things that seem like you can trust them but shouldn't be trusted should be explicitly called out in that way. So an example would be a user-supplied crypto address that money can be sent to, where the expectation is that whenever that crypto transaction is executed, the address is verified at that point. It's not necessarily like you might verify it when the user enters it into the system, but the security of your system relies on it being verified each time a transaction actually occurs. In a case like that, I would probably label that field in the database like untrusted underscore crypto address or something, just so that anybody that doesn't really know how it works sees that and they're like, oh, untrusted, what does that mean? And maybe that you have a code comments and other people on the team that knows what that means. But I just take this really defensive approach where anything that seems like you can just grab it and use it, but you really can't, is explicit everywhere in the code base. This helps a ton. It just makes it so it's a lot harder to make silly mistakes where somebody's like, oh yeah, I just plopped the address in here and created the transaction and sent the money over. And then somebody else is like, what? You can't do that. You were supposed to do this other thing first and whatever. And maybe you created this library to handle it for you, but somebody comes in to refactor it and they don't know about that. They should, but hey, the CEO wants this done yesterday, right? We all know how it goes. So I try to always do this in cases where it's surprising, where you're like, oh, this is sort of unusual or surprising. I try to call that out in any way I can. Another thing I do is assume the worst case scenario. So when I'm working on some level of the code, I'll just assume that all the security before it failed and somebody is able to access the data. I look at it and go, what are the consequences? Is there anything we can do to store less data or separate some of the data into a different system or encrypt it per user account or something like that? So I just try to have this general approach of, oh yeah, our other security mechanisms failed. What can we do to make this specific layer more secure? And of course, like I mentioned before, complexity is the enemy. Do not make things vastly more complex to try to make it more secure. Instead, try to design better code. Complexity just creates more paths to secure and more code to understand. And I call this out because the tendency when you find a potential vulnerability is to be like, oh, we can plug this by adding this additional mechanism. But now you have to secure that additional mechanism, which increases the surface area. And it's not like a linear thing either. It's kind of like an exponential increase the more code you add. So in my opinion, I always push for taking a deeper look at how you can re-architect the code to eliminate the vulnerability altogether or secure against the vulnerability in a more systemic fashion. This is a really important. A lot of times you'll find a vulnerability and there'll be like pressure to like just solve it right away. And the initial instinct will be, oh, let's add this extra layer. Let's add this extra stuff. And maybe that's what you do temporarily to just get things moving and sort of more secure. But it's a really bad idea long term. Just try to resist that urge. Try to be like, okay, is there some way we can do this where we don't need to make it more complex? Complexity around security code is always a big red flag to me. If I get into some code and I'm like, wow, they made this so complicated, trying to make it secure, it's like, I'm really unsure this is going to be very secure at all. There's just too much to keep track of. And another just sort of final reminder is don't write or implement your own cryptography unless you're a crypto expert. That means something different these days. Yeah, don't write this stuff on your own unless you know what you're doing. Ideally, always use well-tested, well-documented libraries that handle security and authentication, login, things like that for you. This is just, yeah, I don't find a lot of people end up trying to do this because it seems overwhelming anyways, but I have. So yeah, do your best to not write, just don't write your own crypto. Let people that are experts at it do it. If you're an expert, you'll know it, I guess, and you're fine. But for the rest of us, like, just don't do it. Don't be like, oh, this is too slow. I need to re-implement it in my language that's faster, whatever. Just don't do it. It's a bad idea. You're only going to create headaches for yourself. Use stuff that is well documented, well tested, has a good track record. Don't do it yourself. All right. Well, that was a massive dump of information. Hopefully it's useful to you and it gives you at least a starting point. Yeah, if you want to know more about a specific part of this, feel free to send me a message from thereactshow.com or come join the Discord server. I'd love to hear more, or if something wasn't clear, definitely let me know. I just want to thank you all once again for joining us. And, if you've made it this far and you want, definitely check out the premium feed, like I mentioned at the beginning, or joining us on Discord. We'd love to have you there. Anything, that we can do to support each other, something I'm all for. Anyways, thank you so much for making it this far, joining us, and I hope you have a fantastic rest of your day. Bye.